Good afternoon, everybody, and welcome again on a Tuesday morning meeting seminar. Today, we invited Dr. Andrea Arrighetti. He's going to talk about archaeology and new technologies, some recent experiences in L'Aquila. He is a research fellow at the Department of Human Science here in L'Aquila, University of L'Aquila, adjunct professor of archaeology, of Architecture, Department of Historical Science and Cultural Heritage, University of Siena. He has done a PhD in L'Aquila again many years ago at the former Department of History and Comparative Methodology. And also has been a research fellow at the University of Florence, University of Siena. He's an expert in architectural archaeology, archaeoseismology, and surveys. His main interests are aimed at the study of the construction systems of historical buildings, in particular the medieval one in Italy and abroad, and the experimentation of photogrammetry, also laser scanning, and as you will see during the seminar, also with studies about structural materials and the survey of movable and immovable cultural heritage assets. He has done a lot of research activity, participated in many archaeological excavations with University of Florence, University of Siena, also substantial activity of stratigraphic readings and elevation and surveys in Italy and abroad, Spain, France, Jordan, Israel, Lithuania, and Greece. He has carried out theoretical and practical teaching activities within last 3 years, specialized at specialized university courses, superintendencies, master and doctoral schools in archaeology, architecture in Italy, Spain, and France, all related to archaeology, architecture, and technologies for the survey of historical buildings, and more in general of cultural heritage assets. Participated as a speaker at numerous national and international conferences and conventions, focused on the themes of medieval archaeology, architecture archaeology, and new technologies applied to cultural heritage. He is an author of more than 70 scientific publications in these topics. So I will shut down now and leave the time to Andrea. Thank you again for your talk.
So good afternoon to everyone. Thank to Professor De Gasperis to my presentation, and thank to invite me to present some recent experience that I made in Tuscany and in the Abruzzo in the last years. In specific, in this short presentation, I'm going to present you the use of two different types of technologies, laser scanner and photogrammetric survey, and their application to the archaeological analysis of excavation and historical buildings. The project that I'm going to present were realized with the collaboration of different institutes and universities. In particular, I would like to thank the University of Florence, Professor Giovanni Minutoli, Professor Giovanni Pancani, and Professor Stefano Bertocci, the CNR of Florence and Pisa, and my students and colleagues that collaborate with me to the realization of the different kind of research. The first part of the presentation concerned the presentation of different way to make a survey of archaeological artifacts. In the second part, I will present some specific experiences gained in different type of context for different projects. Before to speak about the technologies, it's important to think about the fundamental concept of documentation of cultural heritage, and to its implication in the analysis and the transmission of digital products inside the research panorama. The documentation of cultural heritage should be carried out in the objective way and provide a work tool that can be used both today and in the future for different goals and by professionals working in various fields: archaeologists, architects, restorers, engineers, art historians, and so on. For this reason, the documentation of artifacts, whether it is a building, a single object, or an archaeological site, requires tools that are able to provide maximum objectivity regardless of its goals. The objectivity, the storing, and the transmission of the digital data is a really important concept that stands as a transversal node between different disciplines. When we make a survey or produce a digital product of an artifact, we must think that our type of digital product should be used now for the archaeological analysis, but could be useful also in the future, for example, to engineers or architects for vulnerability analysis or for project of restoration, to art historians for the study of fresco or some specific representation, and so on. For this reason, it's really important that our survey must be readable and usable to different professionists of different disciplines, and must be stored and uploaded to different type of format that change during the time following the evolution of the technologies. But this is a really problematic thematic, and I think this is not the right place where we can discuss it. Survey is one of the fundamental means of documentation. Technology, today more than ever in continuous evolution, offers us various ways to take. The choice of one or more of these paths depends on many factors: economic, technical, practical, or simply mental. A fundamental prerequisite in choosing a survey method suited to our needs, however, is to know the characteristics of the instruments that on the market today and the type of documentation connected to them. This is an example of some technologies today used for the survey of different type of context. For example, in the upper part we can see the technologies used to survey of big context of some kilometers. To the survey of this kind of area, we must use aerophotogrammetry or aerial laser scanner with GPS. In the lower part, we can see the instruments used to survey little products, as single artifacts or part of it. In this case, we use photogrammetry, microphotogrammetry, triangulation laser scanner, and so on. So it's really important to have a correct knowledge of the different characteristics of the different instruments to understand the better way to our needs. Concerning the survey, we have two different types of methods. The direct methods that concern measurement made in direct contact with the artifacts to be documented. And we can choose the indirect method survey that concern measurement made and returned through optical, mechanical, and computer tools, graphic transposition of the artifacts, and placement within a system of special coordinates. These are some examples of instruments used for the direct survey. Meters of different typologies, for example, in the upper part, or distance meters, or plumb line, and so on. And these are some examples of direct survey of a room on the right and an architectonical element on the left. In this example, we use the trilateration method based on the identification of the measures of an environment based on two known points. This is the example. We have the two known points, and we find two different measures starting from the measure that we take from these 2 points. Another example of direct survey is the analysis using an optical level to measure the different heights of the ground. This is an example of the survey with an optical level, a direct survey to understand the heights of these two different parts of, for example, an archaeological excavation. Now we move to the 3D technologies. The first example of the indirect survey is the application of laser scanner. Laser scanners are instruments capable of measuring the position of hundreds of thousands of points that define the surface of surrounding objects at very high speed. The results of the acquisition is a very dense set of points, commonly called point cloud, which can be viewed in a three-dimensional graphic file. In this slide, you can see an example of laser scanner survey on the left part and a survey project to the acquisition of 3D scans of a complex archaeological site. In this case, the example is the archaeological site of Rocca San Silvestro near Livorno in the south of Tuscany. The project of scans is the most important part of the work field, because in this part of the project we study the better way to survey the context. In example, the number of points of the point cloud, the number of scans, and so on, in relation with its complexity and the environmental problems that could be interest to the context of study. And this is the example, this is one of the laser scanners that we use during the survey of the Rocca San Silvestro archaeological site. This is the laser that acquire all of the data when moved on the surface of the object. And this is the survey project that we made to survey all of the site, all of the archaeological site. All of the points are one scan realized inside the archaeological site. This is some examples of restitution of single scans. As you may see, they are geometric representation of the area around the laser scanner shown by millions of points in grayscale. All of these scans produce one point cloud of all of the surrounding area of the laser scanner. And this is the example of two scans of 2-point clouds realized by two scans of this archaeological site. After the work field, the first part of the processing of the laser scanner survey in laboratory is the registration of the point cloud. It consists in the production of a single big point cloud of the entire object, starting from the integration of the different scans. This is an example of the point cloud of the archaeological site of Rocca San Silvestro. So, all of these scans produced by only single scan inside the archaeological site were integrated to produce a single, only one entire big point cloud of all of the archaeological site or of the building of the object. This is an example of a restitution of a single laser scanner survey. As you can see, we can see all of the geometric complexity of the object with the column, with the texture of the walls, all made by millions of points in grayscale. After the registration of the point cloud, we use it as a 3D model to cut in different reference planes to obtain sections and plans of interest. Here are some examples of cutting of the point cloud of the cloister of Monastero of Camaldoli near Arezzo in the southeast of Tuscany to obtain two plans at 1/2 meter of height and a 20 centimeter of height. This is the registration of the inside part of the cloister of the monastery of Camaldoli, and this is an entire point cloud of the internal part of the cloister. We decided to produce two different plans at 1.5 meter of height and one at the ground floor. So to produce it, we have only to cut this with a horizontal line all of this point cloud as it. This is, for example, cutting the point cloud and at 1.5 meter, and this is the cut of the same point cloud at the ground floor. As you can see, this is really simple to look to the particular of the plan of the object, and we can import this data to an AutoCAD software to realize the plans or the section or whatever we want. This is an example, a video that shows you an example of a project that we made in Rocca Calascio with a laser scanner, a project that was made in collaboration with the University of Florence, and we made a laser scanner survey of the entire object, the external and the internal part of the object, and a photogrammetric, I show you later, the photogrammetric survey of the building. In this case, you can see the 3D point cloud of the object. We are moving inside our prospect, inside our software, and now you see the box that could be used to cut the object to realize, for example, a section, a cross section of the half of the building, of the vertical building. Yes. Okay, after the cutting of the point clouds, we can use the line produced from this operation as a section to digitalize in CAD to obtain plans, section, or elevation of the buildings wherever we want. So we can cut, for example, this is the plan of the entire site of Rocca San Silvestro. We produce these plans cutting the archaeological site at different level, at different height. So after the cutting of the single area and of the single building, we produce the entire plan of the archaeological site, and we produce also the heights, the different heights, as you can see here, with of the mountain where the site was built. As the laser scanner survey, the laser scanner survey is also important to the analysis of the plastic deformation of the surfaces of the building. This is an operation based on the georeferencing of the single point inside the point cloud, and to attribute to the single point or to some specific area different colors in relation to the shift of these points from a vertical plane of reference that we set. In this slide, you can see an example of this kind of analysis, where the deformation of the elevation of this building is characterized by a yellow and red colors that show with a precision based on centimeters this kind of structural problem. This kind of diagnostic analysis is really important to highlight structural problems related, for example, to damages caused by seismic movements. Here you can see this part is yellow and red and represent this deformation that we show that we can see in the surfaces, in the external wall of this building. And we have this representation with a precision of millimeters. In archaeology, this is really important to relate the stratigraphical analysis of the buildings, the method that we use to understand the historical evolution of a building during the time, with structural problems to understand the chronology of the activation of these problems and the interpretation of the interventions, restoration, reconstruction, after these events. Here you can see this prospect, this elevation is the lateral wall of the church of San Remigio. It's a Romanesque church inside the city center of Florence. Here you can see the stratigraphical analysis of these buildings, of this wall, with the stratigraphical units, the individuation of stratigraphical units. Stratigraphical units are the single action of construction and destruction that the natural or anthropic movements or transformation made on the buildings during the time. We can read the walls to analyze, to identify and analyze this kind of transformation and to understand how the building changed during the time, the evolution of the building. This is an example of the analysis of the single action of destruction and reconstruction in this building, and this is a representation of the same analysis but in phase of construction. Here you can see that the building was the first part of the building was built, was this one in green, and was with the number 2, and was of the Romanesque period. After this Romanesque period, we have the reconstruction of the building in white in Gothic period. The third part of reconstruction was in the 15th century, and in this period was reconstruct all of the roof of the buildings and all of the 3 big windows. So in putting in relation this analysis, this archaeological analysis, with the deformation of the surfaces, we understand some specific interesting data that was used for archaeologists, for us, for the archaeologists, but also for the architectonical project of restoration. For example, we have these 2, you can see in this prospect, we have 2 big parts with a big deformation that was represented by the color yellow and red. The first one was in the upper part, this one, that was related to the structural problems related to the arches, to the big arches and vault that was built inside the church, and the interaction with these arches with the walls create this kind of problem. The other deformation was this one, and was related only to the first phase of construction, the Romanesque period. This was really interesting because relating this deformation to the archaeological analysis of the surface, we understand that this deformation was related to the seismic event that affect this building, maybe in the 13th century, and caused the collapse of the roof and a part of the building that was reconstructed after in a Gothic period, more height and more long than bigger than now. As the laser scanner survey, also for the photogrammetric survey, the most relevant part of the work field is the survey project. Now I'm going to show you the second method that I'm going to present is the structure from motion survey, or the photomodeling survey. Photomodeling consists in the possibility of reconstructing the geometry of a three-dimensional scene, not only by indicating the dimensions, position, and orientation of the volume present in the scene, but by deducing these parameters by superimposing the characteristic components of the primitives used directly on the images, basing on the knowledge related to the projection into space. Image-based modeling and rendering, the modeling based on images, that's called structure from motion, constitutes a fundamental step in the evolutionary path of the photographic instrument within the practice of surveying. As the laser scanner survey, also for photogrammetric survey, the most relevant part of the work field is the survey project. Since the survey is based on photographs and the superimposition of these, the project is based on the morphological complexity of the context of study and on the environmental characteristics of the area of study. Some elements as the quantity and differences of light, the presence of morphological complexity of the object, the partial visibility of some parts of the artifacts, the space in front of the object to realize the photos, the heights of the object that impose photos from different altitude or are some examples of kind of problems that we must study and solve in the project phase before making the survey. So the first phase of the survey was the acquisition of raw data. This is an example of a photo. We have to follow some rules for a correct data acquisition. For example, we don't have to stay in a single without movement to make some photos, but we have to move during the acquisition of images. We can acquire the image with a superimposition of almost an half from an images to another to have the comparison to these two images. So we have specific rules to follow. This is an example of 5 photos of these elements with the production that are used to product a 3D model of this object. The second step, after the acquisition of data, we start with the production of the 3D model based on the photos made during the work field. This phase is composed by 2 big parts. The production of a color point cloud, and this is an example. The point cloud is almost the same that we produce with laser scanner and have an attribute of RGB, red, green and blue, of all of the points that compose all of the point cloud, and this is the base to create the third step, that is the texture model. The texture model was created in with the transformation of the point clouds. All the point clouds was, all the point inside the point clouds was linked by line to create a triangulation of the entire model. That all of the triangle we imposed for all the triangle a surface, and we create a mesh model. A mesh model is a model that have this surface was characterized by point and line, but have inside the triangle we have a surface, and this is the base where all of the photos was linked with this mesh to produce a 3D model with a high definition images on the surface, and this is called the texture model. This is an example of a texture model, and this is the process that we use, the schematic representation of different phases made by the software to produce a 3D texture model, starting from the photos and passing by the production of a sparse and dense point cloud. These two are point cloud with a lot of point color by the attribute red, green and blue, and the mesh model, and finally with the application of the images, the texture model. This is an example of the survey, the extraction from motion survey made in the castle of Rocca Calascio. Here the acquisition was made by a drone, and you can see we survey not only the castle but also all of the area that was around the castle. This is really important because it's very nice to see, but it's very useful also, for example, to understand some characteristic of the material and of the site that we can see with the laser scanner survey, and the integration between laser scanner and this kind of product. With the integration we can realize, for example, some products like orthophoto or like 3D model, virtual tool 3D model or something like that, that is very, very interesting and useful for the documentation and the valorization of cultural heritage. This is another example that we made in the archaeological site of Rocca San Silvestro. This is the acquisition of image made by a drone. All of these blue square are one photo that was made by the drone around the site. And this is the 3D model of the site that was made by the drone photogrammetry and partially the 3D modeling to create the surrounding area, all of the trees and so on, to create the context around the archaeological site. And this is an example of a restitution of a 3D model starting from the structure from motion survey. Okay, starting from this model, we can create, for example, a visualization, an interpretation of the site based on, for example, archaeological data or cartographical analysis or historical sources analysis to create a 3D model of a specific chronology of this site. For example, this is Rocca San Silvestro. This is a representation of the archaeological site in the 14th century. And this is the data that we acquired after the 20 years of excavation made by the University of Siena and Professor Riccardo Frankovic, and the analysis of the building techniques, the archaeology of architecture made on the buildings during the time by Roberto Parenti and Giovanna Bianchi. And here are some examples of projects based on the integration between laser scanner and photogrammetric survey. I choose 4 different examples of projects realized with different goals to show you better the useful of the integration between these 2 techniques. One is the project of restoration, one is the virtual tour, virtual walking inside an archaeological site, one is the archaeological analysis, and one is the characterization of building techniques. The first example that I'm going to show you is the survey, the integration between laser scanner and photogrammetric survey to the analysis of the construction history of an historical buildings. This is an example of the work that I made with Professor Giovanni Pancani in Santa Maria Buiano in Arezzo, in the southeast of Tuscany. This is a really beautiful church, parish church, one of the most important inside the Casentino. And here in this church, we made an integration between the 2 methods. We plan a 3D survey with the laser scanner of the entire buildings, inside and outside, and we plan a close-range photogrammetry survey, photogrammetry made by foot, not by drone, of the entire buildings, inside and outside. By the integration of these 2 kind of products, we produce a lot of section, for example, like this one, all of the elevation, internal and external elevation, the plans of the buildings, and so on. But all of these materials was used to understand, not only to realize a specific documentation of the actual state of conservation of the building, but also to make the stratigraphical analysis of the building to understand its evolution during the time. Here, an example of the stratigraphical analysis made in a prospect, in an elevation of this building. Here you can see the apsidal part, the external apsidal part of the building, where we have 3 big transformation. One, the line in violet are the the line that divides two different stratigraphical units, two different construction activity. In this example, we have the lower part that is an activity, the medium part is another activity, and this line, as you can see here, divide a third activity. As you can see, all of these buildings were very bigger than the one that we see now, because they are one of the most important building church inside the Casentino, but due to seismic event, maybe in the modern era was collapsed, and the lateral naves, all of the lateral naves, remains only the single nave, the central nave, and for 1/3 part of the entire building, of the ancient building. This is the same representation of the evolution of the building, but for phase of construction. So we have the first phase of construction that is concentrated in the lower part of the building, a second phase of construction more higher, and a third phase of construction in the upper part of the building. All of these materials, all of these analysis, archaeological analysis made on the walls of the building, with the integration of historical sources that we found in in archives or in bibliography or in cartography and so on, led us to produce the evolution history of the building. And so we understand that the first church was of the first period. The first church was built about in the 11th century, and this is the morphology of the first church. A very big church with 3 apses, with 3 naves, and very, very long, and higher than the actual church. In the second period, about in the 13th century, the church was divided in 2 parts. The height was lower, okay, and in the lower part was realized a crypt. This is the crypt of the church that was in the first period the ground floor of the church. The ground floor of the first church was here, and now this part become, and in the second period this part became the crypt, and the ground floor was here. In the third period, the church, maybe due to the seismic event with an epicenter in Bibbiena, was retransformed, and the facade and the lateral naves collapsed, and so there was the church was reconstructed with the actual morphology, the actual dimension. So, as you can see from the analysis of the building transformation with stratigraphical unit, we understand this kind of evolution of the buildings. The second example was the integration of the survey for the project of restoration. In this example, I show you an experience that we made in Rocca San Silvestro after almost 5 years ago, for the restoration of the upper part of the archaeological site. This is the plans that I show you before, with all of the walls and the rooms and the buildings that characterize all of the site. And for all of the part of the buildings, we produce a very specific documentation made by elevation of all of the buildings and plans of all of the buildings. Here are an example of the church of San Silvestro, where during the restoration we made an excavation of the internal part of the church, and we produce a lot of documentation, a 3D documentation of the excavation during the dig. A specific survey was made also for the elevation, for the external and internal elevation of all of the buildings. This kind of documentation was very useful, was made in orthophotos and in digitization of this orthophoto, and was very useful, for example, for analysis that was related to the decay of the surfaces, for example, or to analyze the mortar, the presence of mortar inside the joints of the walls, or something like that. So very important, not only to the documentation of the site, but also as a base to specific analysis for the project of restoration. In this case, we don't realize an archaeological analysis of the walls because the site was was studied in 20 years by the University of Siena, and all of the buildings was just studied. So we don't repropose another analysis. The third example is the documentation of building techniques, the survey for the documentation of building techniques. Here is the castle of Rocca Calascio. We made, as you saw before, we made a laser scanner survey and a 3D model survey, structure from motion survey. The integration between these two kind of surveys produce a lot of documentation like this one. This is an orthophoto, for example, of the of a lateral part of the castle. This is another orthophoto that show very well the geomorphology, very interesting, of this site. And we make all of the orthophotos and all of the section of the inside of the walls to study the stratigraphy of the castle. The stratigraphy was useful not only for the analysis of the evolution of the building, but also to the characterization, the specific documentation of the single building techniques that was present, that we find inside the castle. So, for example, this is four different building techniques that we find inside the castle, and all of the techniques correspond to a different phase of construction. And this is really important to understand the evolution of the building techniques for a site or for a territory. And this is also really important to understand the correct project of restoration of this part of the building, of the different part of the building. The last example is the virtual tour, the survey for the virtual tour. This is an example that we made 3 years ago in the Etruscan tomb of La Montagnola in the city of Sesto Fiorentino near Florence. The Etruscan tomb of La Montagnola is one of the most important and well-preserved monumental Etruscan tomb of Italy. It's very interesting because it was composed by a dromos, external and internal dromos, 2 different rooms, and one finally tholos with a central pillar and with a dome that was not a structural dome, but was a false dome that was realized with the superimposition of some block, very big block of pietra alberese stone. This is really interesting site. In this site, we made a laser scanner survey to produce a 3D model of the entire of the buildings. Here you can see the point cloud, the color point cloud made by the laser scanner of the entire part of the internal part of the tomb. And this is some products that we produce after the survey made by laser scanner and photogrammetry. For example, a correct plan of the tomb and cross-section, longitudinal cross-section of the building. But the most important thing is that this kind of products was re-elaborated by the CNR of Pisa and Florence to realize a walk-in to virtual tour inside and outside the tomb. This is an example of the tour that we can make outside the tomb. You can, if you want to try, you can go to the internet site of Comune of Sesto Fiorentino. You can digiting in Google virtual tour La Montagnola or Etruscan tomb La Montagnola virtual tour, and you can make the virtual tour both outside or inside the site. Here you can see the external view of the virtual tour. You can interact with the model, and you can see with the model in section, in plan, or in transparency, or entire model like this one. So you have 4 different modes to interact with the external part of the site. But you can also try the internal walk-in tour of the site. For example, this is the internal tour. You can move inside with your mouse, as you can see in the right part of the screen. You can move with your mouse and with the plants inside the tomb. You can look around wherever you want, and when you find something of interest, you have the point of interest that you can choose, and in all of the point of interest you have some information with the photos, with some written information of all of the part that is more interesting inside the tomb. This is the most important thing, that this is not a photographic virtual tour that was created only like Google Street View with orbital images, but it's a 3D model. It's a light 3D model because the model ran in internet, but acquired a lot of high definition when you stop yourself inside the tomb and you look around. All of you, all of the view in around of your position acquired a high definition, and you can appreciate all of the definition of the object. So, other technologies that I would like to explain very short is the GIS that was really used inside the archaeological analysis of the site. Are the GIS and another the RTI that was experimented in some sites, and I show you after what is. The GIS, or GIS, Geographic Information System, is a framework for gathering, managing, and analyzing data. Rooted in the science of geography, GIS integrates many types of data. It analyzes spatial location and organizes layers of information into visualization using maps and 3D scenes. With this unique capability, GIS reveals deeper insight into data, such as patterns, relationship, and situation, helping users make smarter decisions. This is an example of that was coordinated by Professor Alfonso Forgione in the site of Amiternum, and here you can appreciate some specific of the GIS with this application to an archaeological site. The GIS software is a very interesting way to link different views of the site in different scale. For example, we have this visualization in this scale, but you can go also in this type of visualization with this model of the surfaces and the 3D simple model of all of the buildings that was found during the excavation, was present inside the site. But with the technology, with this technology, we are able to understand the evolution and the relationship of a single part of the site that we are studying, clicking the part of the excavation that we want to see. For example, we can understand the relationship between some buildings, but we can also understand the relationship between buildings and artifacts found inside them. All of the part of the site that we are studying can be drawn, and we can create a different layer starting from our needs. So we can draw the single buildings, but we can draw also the single artifacts inside the buildings. And we can interact, we can make an interaction between this, the larger part and the lower part of the building as we want. In this way, we can have a diachronic view of the site from the general, for example, for cartography or planimetry of the site, to the single artifact. And all of the graphic data was linked to a lot of sheets, here for example, that show all of the information regarding the elements linked to them. So we can appreciate also the graphic part of the GIS, but also all of the information that we can add to a single part of the GIS, of the building, of the artifacts, in PDF or images, or all of the information that we want to have inside the database collected to the GIS. The second technology is the RTI, Reflectance Transformation Imaging, that is a computational photographic method that capture a subject's surface, shape and color and enable the interactive relighting of the subject from any direction. RTI also permits the mathematical enhancement of the subject's surfaces, shape and color attributes. The enhancement functions of RTI reveal surface information that is not disclosed under direct empirical examination of the physical object. This is an example, this is a moment of acquisition of data inside the tomb of La Montagnola. We experimented this kind of software, of technologies for the acquisition of the graffitis, of the inscription that was realized in these two big stone that are the lateral part of this door of these rooms, with this kind that was not visible or very low visible with the eye, with eyes, and we experimented this kind of technologies to acquire this kind of information. To this purpose, we divide all of these two big stones in part. This is in 30 for 40 centimeters parts, and for all of this part we realize some photos. The program, the technologies is based on single photos, a lot of photos made in the same position of the same object, but for all the photos we move the light. For example, here are an example. We produce a lot of photos of the same object without moving the camera, but moving the light in all of the part of the object. The software collects all of these images, and this is an example of one images and one inscription that was present inside, on the surface of the stone, and the process, the software process all of these images and create a sort of 2D model where you can interact with the light. You can move the light inside on the surface of the object, and you can appreciate all of the little transformation that you can see on the surface of the stone. This is an example of one of the photo that we make in this stone, and this is an example of the restitution of the same part of the wall, but with RTI software. So the quality of the representation was very, very high. You can see here, for example, the inscription with all of the line that was not only anthropic line made by human, but also the degradation or the characterization, the natural characterization of the surface of the wall, of the stone. So it's really, really interesting because this line is, I think, 1 or 2 millimeters. So you can understand how the quality, the high definition of this kind of products. This is another example of this kind of horse that we can see on the surfaces of the stone. The last part, and here I end my presentation, is the one work in progress that is near l'Aquila, and I would like to show you. So it's near of you. It's the church, the job that we are starting in the church of San Massimo in Forcona. San Massimo in Forcona, maybe you know it. It's a very important church near l'Aquila. Maybe one of the first church, very, very important before the construction of the city of l'Aquila. And the church was really interesting because it was not well preserved, but the walls is very well readable by the archaeological analysis, and we can understand by the analysis of the walls the evolution and the transformation made during the time on this site. This site was see.
Sorry to interrupt. Since we are going to be late, so
this is the last
some
slide.
Questions. So please, can you conclude in 1 minute?
Yeah. This is the last slide. This is we make a 3D survey with laser scanner. Here are some example of section and plans and visualization of the laser scanner. Also in some parts with the RGB. With the color point cloud. This is some example of the laser scanner survey with section. We made also a drone survey of the building to acquire all of the data for the production of a texture 3D model. And finally, this is a demo version. This is a work in progress. So you see for the first time what we are trying to realize in this site. It's a virtual tour inside the site, the church of Forcona, but not realized as the tomb of La Montagnola with the interaction with the mouse, but with the oculus, with some specific glass that permit to walk inside the church, and that have an immersive virtual tour exactly inside the church, as you could be inside. Here, the last slide.
Okay.
And now I finish. Thank you, and sorry I'm going very, very long.
Thank you, Andrea. Very, very interesting. I clap for everybody.
Okay.
There are some questions. I don't know if we can answer quickly. For example, can you kind of measure something ahead of time, prior to the excavation, for example? Or can the laser technology allow the discover a new archaeological site, new areas, or in a known archaeological building?
Yes, so in the laser scanner survey, not in particular. We have to use the diagnostic analysis like the magnetometry or help me,
Probably with the radio signals.
See, yeah.
It's a radar survey.
Yeah, that is really, really important to understand because they work down the floor, down the ground, and so they understand what is under the ground. But the laser scanner not. The laser scanner create a surface of the ground, so we can have a specific measure of what is on the ground, but not outside. Is interesting the application of the drone survey, because with the drone survey we can create an elevation model, so with the color, that can help to understand if in the geomorphological ground of some specific area we can see some difference that show the presence of the walls or under the ground. But it's not a diagnostic analysis. It's not a diagnostic instrument.
Yeah, for example, Anna Teti was suggesting if there are some studies done in this way, Castel del Monte in Puglia, which is very well preserved Swabian castle.
Maybe yes, but I don't know, because in Puglia we have two big universities, the University of Lecce, University of Bari, maybe, and the University of Foggia. So maybe we have to ask them.
Okay, I have a just short consideration about this. Is the most closest thing to the time machine, to an archaeological site, right? Because you can kind of reconstruct how it was, the exact historical period, and it would be nice, to visit in virtual reality as it was, with including furniture, for example. It would be interesting to know what kind of furniture and carpets there were at the same historical period, right?
Yes, was really interesting. Yes, the integration between hypotheses and the reality. Yeah. Yes,
because those kind of things they are not arrived to our time. They're destroyed by time. Okay, thank you again, Andrea, and thank you everybody to participate to this very interesting seminar. So
thank you to all of you, and thank you, Giovanni.
Thank you, Andrea. So I say goodbye to everybody, and see you for the next Thursday morning seminar.
Goodbye to everyone.